up in Port Arthur, Texas, and my folks, my mother especially, didn't want me to go near the water. And so my first boat was a little sailboat I bought. I had a paper route, and I bought this little sailboat. It was a Snipe. And they didn't know, my parents didn't know that I had this boat because I didn't tell them because they were afraid of the water. And I have a very funny story I want to tell you. I joined the Navy when I was 17, and I was just a seaman recruit, and we were getting ready to leave on this destroyer escort out of Beaumont, Texas, and we're all standing at attention, and the captain was giving the orders, telling we were going to leave, and families, mothers, daddies, husbands, wives, and all that were waiting just to tell their relatives goodbye. And all was quiet. The captain had finished his command, and all was quiet. And out of this crowd of people, my mother says, "Andrew, don't go close to the side of the boat." Anyway, this lived with me for a long time, as you can imagine how the sailors, my sail felt about this, and it lived with me for months because they would always tell me, "Andrew, don't go near the side of the boat." So that's kind of a funny story about my first experience. So I went to work for General Dynamics, and what happens whenever the new kid on the block? You get the bad job, right? And the job they gave me, I'm a structural engineer, so I'm supposed to analyze structures and see if it's got integrity to be able to take the loads. They gave me this stuff they call paint and bed sheets. All the hotshot engineers, the guys that have been there a while, were working with the high-strength aluminum alloys, titanium, stainless steels, that would work up to strength 250,000 psi, and they gave me this stuff they call paint and bed sheets, which was the fiberglass and the resin. Anyway, there was no mechanical properties available. There was nothing published. So I went to my supervisor and said, "I can't analyze these things because I don't know how strong these materials are." And he says, "Well, you just have to go all over the United States and find out." He says, "The way you do that is you make a travel request, and I'll grant you the permission to do that, and you go everywhere that anybody's done any work with these materials and gather up this information to do the design." Well, as a result of that, I became one of the engineers who knew more about composites than most people in the country, because I'd been everywhere. I went everywhere, from Owens Corning to Forest Products Lab in Wisconsin, Owens Corning, Ohio, to Forest Products Lab in Wisconsin. And as a result of that, I set up the design allowables to design these materials for other engineers could use it. And I analyzed all the structures that had to do with composites on the airplane, the B-58 airplane. This was the first supersonic airplane, and it was an airplane that carried a 60-foot bomb pod that was to go halfway to Russia, launch the bomb pod, and then turn around and return to the United States. And then I was a little bit audacious, so I went to my boss, and I knew that in Grumman were building some boats because one of the vice chairmen of Grumman Aircraft was building sailboats. And so I went to my boss and I said, "There's some space in the back of this building available." I said, "And we can build boats here." And so he kind of smiled at me and he says, "Andy, we're not going to do anything but aircraft, bombers, and fighters. That's it. You're not going to build any boats here. This is not Grumman Aircraft. If you want to do that, you're going to have to do that somewhere else." And so I did that. I thought about that for a while, and then eventually I guess within 18 months I had left General Dynamics and had built Flying Dutchman sailboats. And I was fortunate to have a good customer in Houston, Texas, who was a very fast sailor, Martin Bloodworth, and he was able to take this boat and get some recognition for it. And then I sold 4 boats in Chicago to the team that they wanted to sail in the '68 Olympics, and our business got to going, and here we were building the only successful Flying Dutchman sailboat in the world. We sold them all over the world, in Norway and Venezuela, Australia. Anybody who wanted to use a fiberglass sailboat bought them from us. So that was our program in the boat business, and that was kind of a rough go too, because I thought everybody would want to have a fast sailboat, because if you have a fast sailboat, you're going to win. So they asked me if I wanted to be in the show. So I said, well, yes. And so I went and I put a sign on the above the boat. We had the boat there demonstrated at the sailboat show, and I said, do you want to win? And I thought that everybody was going to say, yeah, they wanted to buy one of these boats and win. But you know what? They came by and said, where do I sign up? They thought that that boat was going to be given away, and that's what they would win that boat. So I was very naive and found out also that there was only a limited amount of people that wanted to buy a fast, high-performance sailboat. So that was kind of a learning experience there.
I think that's still true today.
Yeah.
Tell me, was there anything unique about how you laid up the glass at that time?
Well, yes, I use all and we had a very successful. There was other people tried to make fiberglass sailboat that didn't do it, but I knew the kind of materials they used because I used the same things we use in the aircraft industry, whereas they were using the regular boat building fiberglass materials, which had a lot of chopped fiber, which doesn't have high strength. So our sailboats were very successful, and that's where we sold them all over the world. And I guess the best sailor in the country, Buddy Melges, sailed our boat. Achieved a bronze medal at Tokyo Bay, Sagami Bay. So.
And I think you sailed with Ted Turner for
yes, yeah, I sailed with Ted. Ted's an interesting guy. What happened, the way I met Ted was wanting to do something to get recognition. He was a very fast fire sailor, and he was the fastest guy in the country, but he also wanted to race cars. And he bought 4 cars and hired a man, an Oriental fellow, to run the race cars for him. And he had 4 of these cars, and so they were had their cars when they're in Sebring, and then the car that won was a Chaparral. And so he went, and that's the way Ted was. He would always look to see what other people had so he could get the best. And so he went and asked him about that car, who built it and how they built it. And so they said, well, the guy in Fort Worth made the chassis, and then we equipped him with General Motors equipment. So I had a phone call from Ted, and he said he wanted to be part of my program, wanted to buy into the company, and immediately sent $50,000, which was a lot of money in those days, but I didn't cash a check. And he called me about 3 or 4 weeks later and says, you didn't cash a check? I said, you don't want to get involved in this. This is not a money-making business. This is. Well, anyway, that made him want to get in even more. So he came to Fort Worth, and so I went ahead and we became partners, and we built boats, and we sailed in the trials for the Olympics. And unfortunately, Ted kind of clutches up when he gets in a pinch. When we were in the fight, we were the top boat. We were supposed to go to Acapulco, but in the end, when we had the final trials, Ted clutched up. We hit a mark. We hit a boat. We hit the starting line too early one time, and so we were not selected to go to Acapulco. And however, we had a lot of fun. Ted was a fun guy to be around. He was always saying, if you can do it, I can do it. And that was his policy. They called it the mouth of the South. And, so anyway, that was my experience with Ted.
Well, tell me about the Chaparral, because I think that's a really interesting story too.
Well, the Chaparral, I was hired by Jim Hall and Hap Sharp from Midland, Texas, to help them design a chassis for the car. And the way I received that invitation was they were trying to find somebody to build a chassis for them. They built the Chaparral 1, which was built by Trousman and Barnes in California. And it was just like all the rest of the cars. It wasn't any different. So then Hap Sharp, who was a friend of Maury Rose, who was a vice president of Chevrolet, of General Motors, said, all right, if you guys had some experience, you're going to try again, I'll tell you what we'll do. And nobody must know anything about this. If you will get this car started and it looks good, General Motors will give you the full use of the tech center for all of General Motors. And we will support you. We will furnish engines, transmissions, suspension, everything for the car. If you have something that looks like it's going to make it. So they said, all right, that's a deal. Because it costs a lot of dough to build a race car. General Motors is going to furnish all this. Well, we got busy doing it, and when I got into this thing, I also didn't know what I was going to be doing. Hap Sharp came to meet with me in Fort Worth. I took him for a plant tour of the General Dynamics where I was working, and he said, saw what we were doing, and he thought it looked good, and then he said that what he wanted to do, since he was the world's largest drilling contractor, he wanted me to design him some buildings that were lightweight, could be collapsed, and they could move from site to site at low cost. That's all I knew. And so then he left, and he called me later on, like a week or two later, and he said, well, I'd like for you to come see the program. I'll pick you up in Fort Worth. Yeah, they had a little Saberliner. And so they came and picked me up. We went to Midland, Texas, and we go through. They had two buildings, one here, one for Hap, one for Sharp. And I walked through these two buildings that had nothing about oil field laydown, nothing about that. They were just cars, Ferraris, Maserati, Coopers, open wheel cars. All these cars were in, all these race cars. And he said, what do you think about this? I said, well, I said, that's interesting. And I said, but when are we going to look at the buildings that you want to get done? He said, well, we have another plan. Do you think you could design a chassis for these cars? I said, well, they already have chassis. What do you want? It's different. He said, these cars are not stiff enough. He said, when you steer the cars, it's an instant before they respond. He says, you don't have to have the fastest car. What you have to have is the fastest speed around the course. It doesn't have to be the fastest car. And he says, one problem is having absolute control, and you don't have absolute control of all the cars that are being built today. We want one with, I said, well, what do you need? He said, well, it needs to be stiffer. I said, how much stiffer? He said, well, I don't know. I said, well, how about 4 times stiffer? I was a little bit audacious. And he said, that'll do. If you can make it 4 times stiffer. So then the next thing was they had a blackboard. Draw me a sketch of how you're going to build this car. Well, I kind of clutched up because I hadn't really thought about it, but I figured I could do it anyway. So as I was walking to the blackboard, I thought about the Flying Dutchman, which had some of the comparable properties. Flying Dutchman hull is only 200 pounds, 20-foot boat, 200 pounds. And it needed to be stiff also to hold the sails to get a good trim on them. So what I did is I just cut the bow off and the stern off of this Flying Dutchman sailboat, drew that same thing in there with tanks and the bow, and I said, this is the way we'll do it. So they studied it a bit, and they said, well, this looks like it might work. We'll get back with you. And within 6 months, they called me and they said, let's do it. So I had made a contract with them, just verbal, and we had nothing written, and I would do this, and they would pay me on a weekly basis for the work I was doing. At the same time, they told Maury Rose at General Motors that they had somebody who was going to build this chassis for them, and it was going to be a good car. It was different from the Chaparral 1. And so they knew that if it's going to be different and better, that was a good deal. So he said, okay, we'll do it. You will work with John DeLorean. John DeLorean will give you the lines for the car. He's going to run wind tunnel tests at Chance Vaught in Grand Prairie, and you will have those lines to build a car to. And so we're building this car, and then Mario Rose calls up and asks Happy, he said, by the way, how's this guy building this car? How do you know it's going to be stiffer? He said, well, he's making it out of fiberglass. So he said, okay, thank you. So he goes back, he goes to the tech center, calls him back about a week later, says, impossible. You cannot substitute fiberglass for steel. You're lost your money, your investment is all gone. He says, we can't help you. Of course, Hap calls me distressed because here's this whole thing falling apart on him. And so I says, Hap, look, I've been working on this stuff for 9 years. I know it's going to work. We're almost done. In a week, I'm going to deliver this chassis to you, and we'll test it, and we'll show you. He said, that sounds good enough for me. Go ahead and continue, finish the car. And so we did. And my wife and I take the car, put it in the back of the pickup truck, drive to Midland, Texas, test this thing. It's on Sunday morning. We test it, and it's not what I said it was going to be. It was actually about 7% better. I was clutched up at the time, though. I said, well, it may not be exactly that, but because people have to do this, and they may not do it exactly right, but I said it's going to be very close anyway. So it was 7% better. So he was so excited that he calls Mario Rose. This is Sunday morning. He calls him and said, this car is better than what I said it was going to be. And Mario said, well, you got to divide that torque by 2 because to know. He says, we divided by 2. That's what it is. And Mario says, okay. And so Hap was so glad he was hitting the car with a hammer, And I said, it's not supposed to be hit with a hammer, This is it'll support the engine suspension, but it's not for beating with a hammer. So anyway, he was very delighted. So we get the car done, and 2 weeks later, here's 6 engineers from General Motors to see what we were doing. And they look at it, and they're really surprised because here's a stressed skin instead of a welded tubular frame. So they go back and they tell him, we can build a better car than he's doing, and we'll build it for free. So we're going to make it out of aluminum. And so I get another call from Hap Sharp, and he says, look, you did a good job. Thank you for the work. Send me your final billing. We're going to do something else now. And then like a week after that, I read in the newspaper, and Jim Hall has run over a 50-foot embankment, wound up 150 feet down the track. He's in the hospital, and I don't know what's going to happen. I'm worried, it's my car. I get a phone call a couple of weeks later, Jim Hall. He says, Andy, he says, I need to talk to you. He said, when can you come to Midland? He said, I'm going to be out of the hospital in a week. I'd like to talk to you. I said, whenever you say. He said, well, I'll be there in 2 weeks. Why don't you come over? So I go to Midland. Here's the 2 buildings there, but there's a new building in the middle. We walk up this building. It says, what you see here, what you hear here, leave it here. General Motors Corporation. So we walk in this building, and they're building these aluminum cars that are just pleasurized. They're just exactly the same chassis that I've got, but they're made out of aluminum. And so we come out of the building. He said, what do you think? I said, well, Jim, the cars will be stiffer, but they're not going to be as tough as the fiberglass cars are. The fiberglass cars have the ability to absorb energy, and they'll be tougher cars. He said, you're exactly right. He says, we get these aluminum cars off the track, and the mesquite creases the aluminum, and the chaparral car, the fiberglass cars get off the track, nothing happens to them. He says, do the other 3 cars that we had, or finish all the job. We want you back on the team. And of course, the rest is history. The chaparral dominated the decade of the 60s. It changed the face of motor car racing forever. It changed the cars that you're driving today forever. All the cars are built with stressed skin today. So that's the story of the Chaparral.
That's a fantastic story. Well,
Based on a sailboat too, and that's the crazy thing, right?
Yes, that's
Based
right.
on a sailboat.
Based on a sailboat, that's right.
so how old were you when you got that? So-
Jim Hall was 29, I was 32, Hap Sharp was 36.
Wow.
And see, Jim had been driving since he was 18, so he knew a lot about driving. Whenever we did the car, he went to England and hired on BRM so he could drive in Grand Prix races for BRM. He tried Ferrari, but Ferrari wouldn't hire him. You had to have a track record to drive for Ferrari. So he was driving in England for BRM, British Racing Motors, and Hap was saying, getting the rest of the car built, the suspension and all the things you have to do to coordinate. And John DeLorean was, of course, learning about cars too. And then he subsequently left. He was chairman of Chevrolet. And he left and built his own car in Scotland or, in England. Anything that you have that needs performance, be it airplanes, cars, boats, whatever, has to be made with fibers, because fibers are stronger than any material available. Stronger than steel, stronger than any material available, and even your high-strength element alloys. Carbon fiber weighs 108 pounds per cubic foot. The strength of it is 1,000,000 psi. Steel, the best steel, alloyed steel, is about 250,000 psi, but it weighs 490 pounds per cubic foot compared to 108 pounds per cubic foot. Glass fiber, not quite as good, but it's 500,000 psi, weighs 160 pounds per cubic foot. So glass fiber is also very strong and will give you better performance than you will with steel. So the reason these fibers are so strong, just like the plate glass in this window over here, you can throw a rock and it'll go right through that window, but it's not a fiber. And what makes the fiber strong is, like I told you, you pull it out of an orifice. It's very small. When it's hot and melted, and you pull it so small that what you've got are molecules latched onto one another, and they're all oriented the same way, and that's why these fibers are stronger than your high-strength aluminum alloys and your stainless steels, your high-strength aluminum steels. Nanofibers are atomic strength, and there'll be 1,000,000 psi, that you can develop. So, but we're a long ways off before we get nanofibers. The longest nanofiber is about 3 inches long. Guy in Nebraska, the University of Nebraska, made that.
You tell us about the St. Lawrence Skiff.
I really believe that I'm in the shape I'm in today because of my activities with the Skiff. I row 6 days a week, about an hour, 45 minutes to an hour, depending on the wind. And I can back that up with my neighbor, Bob Randall, over. He's the architect who built this building for the Sea Star base. His wife, I sold him a boat. I had an extra boat. I had 3 boats, and I only needed 2, one for my wife and one for me. So I sold him one of them. About 7 months after I sold him this boat, his wife called me and told me, he says, "I really appreciate what you've done. My husband is better. He's a diabetic, and he's in better health now. He went for physical, and the doctor wanted to know what he was doing to change his physical condition. And I thank you for helping him there." And that's a fact. And Bob Randall is in better shape today than what he was then. So it's good.
How old are you now?
I'm 86, going on 87.
But the way that the story of how you discovered the St. Lawrence Skiff is also very interesting. Could you tell me about that?
Yes, I had one crewman. He's an architect in Dallas, and this crewman was a Southwest rowing champion for about 17 years. And he had been racing this St. Lawrence River skiff for a long time. And he was always asking me to build a skiff. And I said, "John," I'm retired. I don't want to build any more boats. I'm tired of building boats. Well, we won the race to Veracruz. This was in 2000. We won this race.
Sailboat.
A sailboat race, yeah, from Galveston, 700-mile race from Galveston to Veracruz, Mexico. We won it very handily in this multi-hull. We got in a day ahead of the second boat. And so my spirits were high, and I said, okay, John, tell me about the boat. Where can I get one? I said, I don't want to race, I don't want to sail or row boats like I rowed when I was a kid. I said, they were all heavy fishing boats with a bait box in the middle, weighed about 800 pounds, 16 feet long. He said, well, there are none built in the United States, but he said, you can get one in Canada, not like the St. Lawrence River, but it's close. And he said, I'll tell you when you can do that. And he said, you'll be able to sail all the way across Lake Sabine, which is 5 miles at the neck of it where we sail, where we row. And so I didn't really believe it, but anyway, I went ahead and bought the boat. And sure enough, could row around or 5 miles across this lake, and it wasn't a big deal. Nothing like rowing those fishing boats. And so I called John and said, okay, I'm convinced. Get me the lines of the best boat, and we'll build the best rowing skiff in the world. And he did. And this was a boat named Annie that was a champion in 1886. So he got me the lines for that. We tweaked them a little bit and built, I guess maybe about 25 or 30 of these boats. And they're good boats. They're open water boats, and they're easy to row. They don't weigh a lot. They weigh right in the neighborhood, less than 100 pounds. And they're a fun boat to row. You kind of get addicted to it. You have to row them every day. So that's it. They're just a neat boat to have.
Well, thank you. Thank you very much, Andy. That's